I want to run through a few examples of unit circle problems and make the point about how quick and easy these can be to do. So just a reminder to everybody that the three key values, I'm assuming you know that that's the point 1, 0, that that's the point 0, 1, that's the point -1, 0, and that's the point 0, -1. All of the other points involve only three numbers, okay? And the three numbers are 1/2, which is 0.5, radical 2 over 2, which is 0.707, and radical 3 over 2. And by the way, notice that's the square root of 1, the square root of 2, and the square root of 3. And by the way, the square root of 4 over 2 gives you 1, which is the other number that shows up in different forms on here. So kind of an interesting pattern. Anyway, radical 3 over 2 is about 0.866. So if you know those three values and you know how they relate to each other, if you're drawing a 30-degree angle, you're going over the farthest possible amount, which is radical 3 over 2, and you're going up the smallest amount. So that's the point radical 3 over 2, 1/2. Okay, for a 45-degree angle, you're going over a middle-ish amount and you're going up a middle-ish amount. You're going over radical 2 over 2 and up radical 2 over 2. And then finally, for a 60-degree angle, it's going to look more like this. You're going over a small amount, you're going up the large amount. It's this flip-flopped. So over 1/2, up radical 3 over 2. Okay? And in every single other position on here, you can just use symmetry and whatever part of the graph that matches up with. So certainly if you have a unit circle drawn out, it's great to look at. If you don't, I tend to just fill in the values that I need, which I'm going to exhibit here. So let's take a look at this. So sine of 210. So the whole idea here is you can boil down sine and cosine in particular to much simpler equations. Sine is normally y over the radius, y over r. But if the radius is 1 for all of these values, which it is, sine's really just y over 1, which is just y. Cosine, instead of being x over r, if r is 1, cosine is just going to be x. And unfortunately, tangent doesn't change. I don't think tangent works as well. Anyway, cosecant, of course, is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent, same thing. You can just flip those if you need to. So I'm not going to look at those specific examples, but similar concepts. All right, sine of 210. So basically, you just need to figure out where 210 is. Okay, you rotate around 180 degrees. You drop 3 more 30 degrees farther down. So you have a 30-degree reference angle. Okay, which is going to match up with the points over here. You're going over a large amount and down a small amount. So you're going back -3 over 2, negative radical 3 over 2, and you're going down the short amount of 1/2. Okay, those are the coordinates of that point. I want the sine. Sine's the y coordinate. So the sine of 210, -1/2, just like that. Cosine would be the x coordinate, negative radical 3 over 2. All right, second one, cosine of 5 pi over 4. Remember, pi radians is 180 degrees. 180 degrees divided by 4 is 45. 5 45s would end up being 225. So we're looking for the cosine of 225 here. So same kind of thing. You have to find the reference angle. So you're going around 180, and to get to 225, you drop 45 degrees farther down. So that's going to be a 45-degree angle, which is going to kind of match up with this 45-degree angle over here. That's your, I guess that was actually a 210 before, and this is actually a 225. But the reference angle there is a 45-degree angle, okay? So you're going over a middle-ish amount, and you're dropping down kind of a middle-ish amount, okay? It's going to be the negative versions of these. Negative radical 2 over 2, negative radical 2 over 2. Okay? In this case, we want cosine. Cosine is the x-coordinate, so it's going to be negative radical 2 over 2. Sorry, I didn't leave quite enough room there to put that in. All right? Sine of 3 pi over 2. Pi is 180. Half of 180 is 90. 3 times 90 is 270. So we're trying to find the sine of 270 degrees, okay? 270 degrees, you rotate around 180, you go another 90. 270 is going to be this angle down here, okay? Normally that's a quadrantal angle. You couldn't make a right triangle with that, and it doesn't matter because we know that sine is just the y coordinate of the point on the unit circle. and the y-coordinate of the point on the unit circle is -1. So the sine of 3 pi over 2, just -1. Okay, finally, I'll do a tangent. Again, I don't use a unit circle a lot for tangents. I honestly just use 30, 60, 90, and 45, 45, 90 triangles, just graphed in standard position. But you can use tangent. The problem is, because it's y over x, and most of these are fractions, you get really ugly fractions. And of course, remember, when you divide by a fraction, you just multiply by the reciprocal. So, I mean, we're not talking anything beyond 5th grade math here, but sometimes it is a little bit more work. And the idea of the unit circle is to get fast answers, see where the signs, what the signs are and that sort of thing. So anyway, tangent of pi over 4, that'd be 180 divided by 4. That's tangent of 45, okay? And so if you go over here to 45 degrees, you're going over radical 2 over 2, up radical 2 over 2. It's this value here. Radical 2 over 2 for y, and radical 2 over 2 for x. Dividing anything by itself is just equal to 1. So the tangent of 45 or tangent of pi over 4 is equal to 1. By the way, one other thing that's useful about the unit circle. I could also ask you to find angles that have certain trig values. So for example, I could ask you to find any angle theta so that sine of theta is, let's say, a half, okay? And usually they'll say something like, find a value of theta between 0 and 360 degrees, or 0 and 2 pi, or something like that. They'll do that kind of thing. Anyway, there are actually two places where the sine is equal to 1/2. Now, normally you would have to kind of fiddle around with triangles and try to figure out, okay, I think it's going to link to a 30, 60, 90 triangle because I've got one side that's half the length of the hypotenuse, and you can kind of piece together that opposite and hypotenuse kind of relationship. But check this out. On a unit circle, it's super easy. The sine is just the y-coordinate. So just look for places where the y-coordinate is 1/2, okay? There's a place where the y-coordinate is 1/2. That's a 30-degree angle. So sine of 30, or sine of pi over 6 if you want to work in radians, is equal to 1/2. Okay, now think about other places where the y-coordinate is 1/2. It'd have to be this high up, right? That's going to be this point that's over here that corresponds to it. You've got a 30-degree reference angle here. You'll have a 30-degree reference angle there. You would be going back radical 3 over 2, up 1/2. Okay, and so here's another point that has a y-coordinate of 1/2. What's the angle measure? Well, we're going all the way around to a reference angle of 30. That's going to be 90 plus another 60, 150-degree angle, or 5 pi over 6 if you're working in radians, would also have a sine of 1/2, okay? And those are the only two coordinates on the unit circle that are going to have y-coordinates of 1/2, okay? So you can use that kind of thing too. You can kind of work backwards off the unit circle to find angle measures that meet different requirements. And so that's also something you might want to think about. Just one more example here. Cases where the tangent is equal to 1, okay? Again, tangent is y over x. So you'd be looking for places where these are the same two values, okay? Where does that happen? Well, you've got the same two values there at 45 degrees, or pi over 4. And then the only other place where this happens, we already have it labeled down here, you have negative radical 2 at both the x and the y positions. That's a 225-degree angle. So that would be the other place where that happens for the tangent. So you will see some trig values that are repeated in different places on the unit circle. You don't always see a trig value popping up twice, but in a lot of cases, if you're looking at just an x-coordinate or a y-coordinate, that x or y-coordinate will appear two places in the circle, and as a result, you'll have two different angles with that trig value. So something that we'll continue to think about as we continue to move through this chapter.